All right, so finally, number 20 and 21 from the Math 107 Test 3 review. So number 20 says, the ages of cows in years and their milk production in gallons per week are given in the following table. Okay, so we've got age, milk production in gallons per week. And so we've got age 4 years, 6 years, 7 years, 8 years, 10 years, and 11 years. So 1, 2, 3, 4, 5, 6, 7 cows. I'm missing somebody. 4, 4, 6, 7, oh sorry, 7, 8, 10, and 11. 8 cows. So our sample size is 8 here. Okay. And the milk production, 37 gallons, 35, 33, 33, 32, 34, 30, and 30. All right, so question A says, which is the independent variable X, which is the dependent variable? So which way is the data? Does the age depend on milk production, or does the milk production depend on age? Well, if you think about this, as a cow gets to a point where they can have babies, calves, then they can produce milk, a mammal, and as cows get older and older, like older women, they end up not being able to have babies anymore, and probably they don't produce as much milk. So the milk production is dependent on the age. So the age, X, would be the independent variable, and the milk production, Y, is dependent on age. That would be the dependent variable, Y. For B, using the data provided, draw a scatter plot. So we now know which is X and which is Y. Here's X, here's Y. Everything's positive, so we're going to draw, and again, all this is better with graph paper. And so this is X, age, and this is Y, milk production, weekly milk production, Y. All right, so X goes from 4 to 11. So I'll count by 2s. 2, 4, 6, 8, 10, 12. If I had more space, I'd count by 1s. I'd do this on graph paper. And then Y, milk production, goes from as low as 30 up to as high as 37. So I'm going to make a break just so I don't have all this empty space. And I'm going to do 30, just because I don't have a space, 32, 34, 36, 38 gallons. Always label your axes, right? And so I'm going to plot these points. So right 4 up 37 is my first point. Right 4 up 35 is my second point. Right 6 up 33 is my third point. Right 7 up 33 is my next point. Again, always more accurate, right, with graph paper. Right 7 up 32, my next point. Right 8 up 34. Then 10:30, right 10 up 30. And 11:30, right 11 up 30. Okay, so here's my data. So that's my scatter plot. So question C says, does the data suggest a linear relationship? So if you kind of look at this, maybe from a distance, it looks like a straight line. So I would say yes, it suggests a linear relationship. If so, what kind of relationship? Well, as X age increases, Y milk production decreases. So this is a negative linear relationship, because as X increases, Y decreases. If this were a straight line, it would have a negative slope. And D, it says calculate R. Now remember, I wrote in the directions that instead of calculating R, you're going to estimate R, because we did not have time to calculate R. So R is the linear correlation coefficient. This has a value always between -1, if it was a perfect negative linear correlation, and +1 if it was a perfect positive. And the closer it gets to 0, the weaker the correlation looks. This looks fairly strong as a line. So I would, if I were going to make this estimate, I would say that it would be, and again, it's negative, I would make it at least something like -0.8 something. But if we were to learn how to do the calculation, which if we had more time and we had been in class, I would have done that calculation and taught you how to do that. It turns out, if we'd gone through the whole process, that calculation turns out to be negative 0.897. But again, what I would expect is you'd say at least negative 0.7, negative 0.8, because it is a negative linear correlation and it's fairly strong along a straight line. Okay, and then last, number 21. Move that up. And so we're going to look at these graphs here in number 21, and we're going to say, state the type of relationship, predicted value for R. Okay, and so these, again, R is the linear correlation coefficient. So we've got A, B, C, D, E, F, G, and H. Okay, we're going to say what kind of relationship and what's a possible value for the linear correlation coefficient R. Okay, so if I look at A, 21A, that is not a linear relationship. That's a quadratic relationship. There's definitely correlation, but it's just not linear. So what we can say here is the type of relationship, it's nonlinear or not linear. So R cannot be used or cannot be predicted here because R is only for linear correlation. If we go to B, 21B, that doesn't look like there's any correlation. There's no relationship between whatever X is and whatever Y is. It's just scattered. So this is no linear correlation, which is different than nonlinear. Nonlinear means it's a curve of some way. No linear correlation. So R, if there's no linear correlation, meaning it's not a curve or something, we would say our R value is something close to 0 because it looks like there's no correlation. If we go to C, 21C, as X increases, Y increases, and it looks like a pretty strong correlation here. So this would be a strong positive linear correlation. Again, we didn't get to learn how to calculate R, but you would expect R to be something positive and something pretty close to positive 1 because it's close to a straight line. So I would say what I put in the possibility there is something around 0.95. Again, how do I know that? Well, I'll talk about that in a minute, but we had some examples in the book, in the textbook on page, I think it was 483, but I'll pull it up when we're done here, that gives some R values based on what the pictures look like. So this is strong. It's pretty close to positive 1, I would say, because it's pretty strong. So if we go to D, it's a more scattered, but it is as X increases, Y decreases. It's a negative linear correlation. It's more weak than this one, I would say. So I would call this a somewhat weak negative linear correlation because it's more scattered than being along a straight line. So our R value has to be negative. And again, it's really just a guess here, but because it's starting to look like it's pretty scattered, I had it at negative 0.4, negative 0.40, something like that. Again, I'm not going to expect really close answers, but it definitely needs to be negative, and it shouldn't be close to negative 1. So it's going to be somewhere somewhat weak. And again, looking at page 483, we'll get some better ideas about those R values. If we go to E, E here is a strong positive correlation, not as strong as it was in C. It's not a straight line, but it's pretty strong. So I would call this a fairly strong or strong positive linear correlation. So we can do an R value. It's going to be positive. It's not going to be as strong as the one we had up here in C because it wasn't as strong as a straight line as C, but it's somewhat strong. So I guessed around 0.75, 0.7, 0.8, some kind of ballpark, 0.6, some ballpark figure of that. If we go to F, this one's easier. In F, this is a perfect negative linear correlation because as X increases, Y decreases, it's a straight line. So this one is a perfect negative linear correlation. For a perfect negative linear correlation, this is easier. R is negative 1. The R value, the correlation coefficient. G is also easier because this is a perfect positive. As X increases, so does Y. It's going up in a perfect straight line. So perfect positive linear correlation. In a perfect positive linear correlation, we can do the R easily. It's positive 1. So R is always between negative 1 and positive 1. The closer it gets to 0, the weaker it is. And finally for H here, as X increases, Y decreases. It's a negative correlation. If you look at it compared to the one above, it's definitely stronger, closer to a straight line. I would say it's a strong negative linear correlation. And so we can do an R value. It needs to be negative because it's a negative correlation. It's going down. And my guesstimate was about negative 0.90. Again, it's just kind of a guess here, but it's pretty close to a straight line, a negative line. Maybe it's negative 0.86 or something like that, but it's pretty strong. So I would call that negative 0.90. So that's it. And again, you are not going to be calculating R, you're just going to be making estimates for R.